Hello students, welcome to lesson 12 on trigonometry. I hope you are all doing well. Good. In our previous lesson, we looked at trigonometric ratios of complementary angles. We understood the concepts and we solved some examples. And then I gave you example 4 as an assignment. I hope you've all done the assignment. Good. So, we'll begin our lesson today with solution to the assignment. Right. So, we're to find the value of x if sine 3x plus 40 equals cos 2x. So, we're to find sine 3x plus 40 degrees equals cos 2x degrees. So, we now understand that sine of an angle will only be equal to cosine of another angle if and only if their sum, okay, that is the sum of the angles add up to what? 90 degrees. So to solve this, we have to add 3x plus 40 to 2x, and then we should equate it to what? 90 degrees. That is what we learned. Okay, so let's look at the presentation. Good. So now we are going to have 3x plus 40 plus 2x equals what? 90. So 3x plus 40 plus 2x equals 90. Remember, they are all in degrees, so that is why I omitted the unit. The unit will cancel out. So we are going to have 5x plus 40 equals 90. 5x plus 40 equals 90. 3x plus 2x will give you 5x. So you now have 5x equals 90 minus 40. Then 5x will be equal to 50. So to solve for x, we are going to have our x to be equal to 50 over 5. Okay, our x to be equal to 50 over 5, and therefore x will be equal to what? 10. So 5 goes here, 1 goes here, what? 10. Good. So students, this is the solution to the assignment. This is the solution to the assignment. The value of x is 10. Now you can check your answer and see if you are correct. So we got x to be 10. So wherever we see x in the equation, we have to put 10 there. So 3 times 10 will give us what? 30. 30 plus 40, 70. Now 2 times 10 will give us what? 20. So therefore 20 plus 70 will give us what? 90. Okay, good. So it means that this angle and this angle are complementary, and therefore this condition holds. Right. So that is all about the trigonometric ratios of complementary angles. Today we'll look at a different concept, a different topic. Okay? Good. So let's look at what we'll be doing today. Good. So our topic for today is finding the acute angle of a given trig ratio. Finding the acute angle of a given trig ratio. Now we will be doing this using calculator. Okay, a scientific calculator. So if you don't have your calculator with you, please go and get it before we continue. So get your calculators ready, then we start. Right. Good. So in our earlier lessons, you've gotten to know that if you have a right angle triangle, okay, where this is theta, the reference angle, let's say this is root 3, and then this is 2, and then this is 1. So if you have this right angle triangle, the sine of theta, sine theta, we know will be equal to what? The opposite of what? The hypotenuse. Now the opposite is what? Root 3, and then the hypotenuse is 2. So sine of theta will give us what? Root 3 on what? On 2. Good. Now, we said that the ratios are in relation to what? A reference angle. So because we don't know the angle, that is why we are using theta to what? To represent the angle. But this time around, we want to know the angle. So we want to know the angle whose sine will give us root 3 over 2. I hope you get it. So we want to know the angle whose sine will give us the ratio root 3 over 2. So how then do we do that? Or how do we get that angle? So using the calculator, or with the help of the calculator, okay, and using what we call the inverse trig ratio, okay, the inverse trig ratio, we'll be able to get the angle theta. So to get the angle theta, what you do is that you find the sine inverse of the ratio. So to get the value of theta, you are to find the sine inverse of the trig ratio. So in our case, if you want theta, then theta will be equal to sine inverse. This is how we write it. So you write sine and then exponent minus 1. So sine inverse of the ratio, that is root 3 on 2. Okay, so the theta is giving us the sine inverse of root 3 on 2. That is the sine inverse of the ratio. So on your calculator, if you punch this one on the calculator will give you a value for theta. Okay, so let me go over. So I said that sine theta equals root 3 on 2. We all know that. But how then do we get the value of theta? What sine theta equals root 3 on 2 means is that there is an angle. When you find the sine, it will give you a ratio of root 3 on 2. So now I want to find that angle. Okay, so we said to find the angle, you have to find the sine inverse of the ratio. So you find the sine inverse of this. So now you write your theta to be equal to sine inverse. So we said that you write sine and then exponent minus 1 before you bring the what? The ratio. So theta is sine inverse of root 3 on 2. So if you punch this one on the calculator, the value that you get will give you the value of what? Theta. So let's see how to do that. Let's see how to do that. So I have my calculator here. Now, to get sine inverse, you have to punch shift. So look on my calculator. I'll punch shift. Then you come to where sine is. Then you press sine. So I have shift sine, shift and then sine. Shift sine will give you what? Sine inverse. Now you have to punch what? The ratio there. So you go for your this fraction form, then you punch root 3, then you come down, you punch what? 2, then you close the bracket. Good. So we now have sine inverse of root 3 on 2 on the calculator. So when you are done, you just punch your equal to sign. Good. And the calculator is giving us the value to be what? 60. So it means that in our case, our theta will be equal to 60 degrees. Our theta will be equal to 60 degrees. Good. I hope you've gotten the concept. Okay? So, whenever a trig ratio is given and you want to find the angle that gave that ratio, what you do is that you find the sine inverse, or you use the inverse trig function of the particular trig ratio that you are looking at. So in our case, it is sine. So you find the sine inverse of the ratio. So with the help of a calculator, when you punch it on it, it will give you what? The angle. Okay, so it means that generally, if I have sine theta equals, let's say, A over B, to find my theta will be equal to the sine inverse of the ratio, which is A over B. Okay, so my theta will be equal to the sine inverse of A over B. Good. So with the help of a calculator, when you punch this on it, it will give you the value of what? Of theta. So students, this is how we find the angle. This is how we find the angle when a trig ratio is given. Okay, so this is in terms of what? Sine. What of this one? Do this one for me. No, this time let's use cos to see whether we've understood the concept. So I have cos x to be equal to 1 over 2. So I want x. How do I get my x? Try your hands on this one quickly. How do I get my x? Good. So we've established the fact that to find the x, your x should be equal to the cos inverse of the ratio, which is 1 over 2. So your x will be equal to the cos inverse of the ratio, which is what? 1 on 2. I hope you get it. So with the help of a calculator, you punch cos inverse of 1 over 2, and then the calculator will give you the value of what? Of x. Okay, so let's see what value we'll be getting. Let's see what value we'll be getting. So let's reset on. And you always have to make sure that the mode is on the general mode. The general mode is 1. Okay, so on the general mode is 1. So now we are to find what? Cos inverse of half. Cos inverse of half. So you punch your shift and then you look for your cos. You punch your cos. So you have your cos inverse there. Then you go for the fraction form here. Then you punch 1. You come down. You punch 2. You shift to close the bracket. Now you then punch the equal sign. Good. So we are getting our x to be what? 60 degrees again. Right. So let's do that. Let's do that. So it means that our x, okay, our x is equal to 60 degrees. Our x is equal to 60 degrees. Good. So students, I hope you've seen something here. We got the value of theta here to be 60. So it means that sine 60 is what? Root 3 on 2. Now we got the value of x to be what? 60. So cos 60 is what? Is half. Right. So it means that sine 60 and cos 60 are not the same. I hope you've observed that. Good. So that is the concept that we are to learn today. To find the angle when a given trig ratio is given, what you do is that you find the inverse trig of the ratio and you use your calculator to get the value of what? Theta, or the specific what? Angle symbol used. Right. So to build our confidence, let's solve some examples. Let's solve some examples. Good. So example 1. Given that sine x degrees equals half, find x. Given that sine x degrees equals half, find x. Good. So we know that we're given sine x degrees equals what? Half. So to find x, which is the angle in question, we know that the x will be equal to the sine inverse of what? Of half. The sine inverse of half. So at this point, you will need the calculator to give you the value of what? Of x. So our x will be equal to, we have to get our calculator. Good. So let's clear this. So we punch shift sine, and then we put in our half. We close the bracket and then equal to. Good. So we are getting what? 30. The calculator gave us 30. Good. So it means that our angle is what? 30 degrees. So our x is what? 30. Our x is 30. I hope you've gotten it. Good, 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 good. Let's look at example 2. So find the value of theta if cos into bracket theta plus 30 bracket close degrees equals 0.1736. Good. So you realize that it's not always that we'll be getting fraction. It can be changed to a decimal. Okay? Good. So the same concept. You take all the theta plus 30 as what? As your angle. That is the x or y or whatever. So the same concept. The cos inverse of this ratio will be equal to the theta plus what? 30. Okay? The cos inverse of this ratio will be equal to theta plus 30. So let's do that. So we know that now our theta plus 30 will be equal to cos inverse of 0.1736. We close the bracket. So at this point, we will need the calculator. Okay, good. So we have to get our calculator. Good. So cos inverse, shift cos. Now you know. So 0.1736. Then you close it. Equal to. Good. So what are we getting? Take note of the value. 80.00280296. Good. Now it's advisable to approximate it to 4 decimal places. So if the digits are too much, the number of decimal places are too much, it is accepted when you leave it to 4 decimal places. And even mind you, the ratio was given in what? 4 decimal places. So it's advisable to leave it to 4 decimal places. So this is first decimal, second, third, and fourth. So when we count the 4, we look at the next value. If it is 5 or more, we add 1. If it is less than 5, we leave it. We leave the rest as it is, and then we maintain what we have. So in our case, 0 is less than 5. So we ignore all this one, and we use 80.0028. Okay, good. So take note of that. So we are going to have theta plus 30, okay, equals 80.0028. 80.0028. So now we have to find theta. So our theta will be equal to 80.0028 minus 30. So when we do the subtraction, we are going to get what? This one will give us 50.0028. 50.0028. Okay, so this is the value of what? Of theta. This is the value of theta. Now, if you are not told to approximate, you can leave your angle in the 4 decimal places. Okay, if you are not told to approximate, you can leave it to 4 decimal places. That is the best way of presenting it. And also, before you even approximate, make sure you write the longer one before you approximate. So if you decide to approximate to the nearest degree, you have to make sure that you write all these 4 decimal places first before you write the nearest degree one. You don't just write it straight away like this one, then you just write 50. It is not acceptable. So you have to write the longer one first before you approximate. So if you are to approximate, then our theta can be equal to 50. Okay, our theta can be equal to 50. Good. So students, I hope you've gotten the concept, right? So now let me give you example 3 as an assignment. The next time we'll meet, we'll look at it and we'll solve more examples on this concept. Okay? Good. So let's see. Right. So this is the assignment. Study it, apply the same concept, and then you solve it. Till we meet again, revise, read ahead. Bye.